Okay, it is domain and range for a third day, but hopefully we're getting more comfortable with it as we go, and that domain and range is not a big deal for you. Again, ask questions if you have them. So what we're going to do today is we're going to do real world applications. Don't be scared by that. This is actually a little easier than what we've been doing. So what we want to do is we want to identify the function. Here's really good news here. They're going to tell us what the function is. So that's not too bad. We just have to write it down. We're going to determine the variable. And what's the input and what's the output? We just want to look at that and make sure that we can clearly see what it is. And we're going to determine the least and the most. So the lowest number and the highest number of the domain. So that we're going to always have to look for. And then like we talked about in day 2, in order to find the range, you're going to have to plug in the domain. So plug in the least and the most of the domain to find the range. Okay? So we're going to refer to these steps as we go through this first problem. Example 1. The Booster Club is selling t-shirts for $10 each. Their initial cost to buy 30 shirts was $150. To find their profit P on 30 shirts is a function of the number of t-shirts sold and can be found using this function. What is a reasonable domain and range for this situation? So the first thing we're going to do is we're going to just identify the function. Guess what, guys? It's right here. P of t is equal to 10t minus 150. We don't even have to make it up. We get to use it, whatever they gave us. Now, what does that mean? Okay, what it's saying is we're $10 for each t-shirt. So T is the number of t-shirts. Okay, $10 for each t-shirt minus the cost of the shirt. Okay, that's the cost. Now, our variable is the profit for range, profit, and that's going to be represented by P of t. So that's our range. This is our domain. Now we're going to look at what is the lowest number, the least that our domain can be. We'll just think logically. If you're selling shirts, what's the least amount you can sell? Exactly, 0. 0 shirts. Okay, and what's the greatest? Well, they tell you that in the problem. Read through it. To find their profit on 30, that's what our range, our domain is going to go to, from 0 to 30. Okay, so that we can figure out. We get to kind of control that. But when it comes to the range, we actually have to find it by plugging it in. So to find the range, I'm going to take the function and find P of 0. That's my lowest domain. I'm going to find my lowest range. So I plug in 0. I get 10 times 0 minus 150. And I get negative 150. Okay, that's the lowest. Let's hope that doesn't happen. Nobody's making money there. Okay, then if I want to find the range for the highest, if I sell all 30 shirts, I'm finding P of 30. So I'm taking 10 times 30 minus 150. That gives me 300 minus 150. That gives me 150. Okay, is this going to be continuous or discrete? Always ask yourself, can I sell part of a t-shirt? Can I use a fraction? Nope. So this one's going to be continuous. Why? Because you can't, like I said, can't sell part of a shirt. Now, when it gets to your homework, we're going to go right to what is a domain and the range. So these are things that you kind of want to step through on your own and maybe mark up the problem. So if I were going through and doing this, I would realize that this is going to be affecting my answer. And there's my function. And what's my domain? And so you just kind of make notes to yourself, because we're not going to separate this out for you every time. We're going to go right to the domain. Well, what's the domain? My lowest value is 0. Now we said this, oh my gosh, look at my mistake. This is not continuous. Hello. This has got to be discrete, because you can't sell a part of a t-shirt. My fault. Okay, so we have to start at 0. I knew it by the time I got here because I knew it had to be set notation, because I can sell 0 shirts. I can sell 1 shirt and 2 and so forth. But we're going to stop at 30. For some reason they're stopping at 30. That's where we have to stop. And again, to find our range, we had to plug in. We always have to plug in our lowest and our highest. So our range, Now on the range, what you want to do is you want to go with the lowest and you want to go with the highest. But what you want to do too is have a couple numbers in between. You don't need to do all of them, but do a couple numbers. So we found P of 0 and P of 30. So let's find P of 1. So we're just going to go over here and find P of 1. We're just going to find the next one in this sequence of numbers. So plug in 1. We have 10 times 1 minus 150. 10 minus 150. That gives us negative 140. Okay? So what we're concentrating on is reasonable domains and ranges. And this is going to be discrete because we're on t-shirts. Okay, here's our next one. A fragile byte, and notice this does not tell you, this does not go through all the stuff with you. It just goes identify and go right to domain and range. So we're going to have to separate those things out. A fragile bacterial cell multiplies at a growth of P equals 2 to the S, where B is the number of bacteria cells and S is the number of seconds. In a controlled environment, the scientist kills the bacteria off with 10 seconds. What is a reasonable domain and range? Now, if I were doing this problem, the first things I would do is start marking it up. So I would mark, here's my function. Just in case they don't ask for it, I know I'm going to have to use it. We ask for it here. That's 2 to the S power. B is the number of bacteria cells. Okay, so B is the number of bacteria cells. That's going to be my range. And S is the number of seconds. This one's not written in function notation. I realize that, but it's still that. That's going to be my range. This is going to be my domain. In a controlled environment, kills off in 10 seconds. Okay, so that's going to be important. What is a reasonable domain and range? First off, is this discrete or continuous? Can I have a portion of something in this? Portion of a cell or a portion of a second? Yes, I can. So this one is continuous, and I'm staying with that. Because you can have a portion or a fraction or a decimal of a second. This is time, and also cells are that same way. Okay? So now let's go and find the domain. So here we go. I can have 0 seconds. Okay, so seconds is this is my domain. I can have 0 seconds, but 0 seconds could be included in it. And how many seconds long did it say we could go? I told you that was going to come back in, and we needed to have that, 10 seconds. Now, how do I find the range? I have to use the domain. So I'm going to take this, and I'm going to plug it in. So I'm going to take B is equal to 2 to the 0 power. And we know anything to the 0 power is 1. So that's where our range is going to start, is 1. And then we're going to plug in. So what we just did is, So anyway, we're going to take 0 and plug it in. And now we're going to plug 10 in. B is equal to 2 to the 10th power. Okay? And that you would probably need to do on your calculator, I would assume. And when you do that, and hopefully everybody knows how to do that, let me just make sure. So we haven't used this button too much. And the button on here for this, I know where to find it on this one. It's going to be, where did it go? Hold on. Okay, that was silly on my part. You just use the caret key. Just use the caret key right here. Duh. Okay, so you're going to take 2, whoops, is that showing up? 2 caret 10. Okay, so you want to take 2 to the 10th power, and that's going to give you 1024. Sorry, brain freeze there for a second. So that means my range, when x is 2 or when s is 10, then my b is going to be 1024. It's supposed to be a square bracket. Okay, good. Yeah. Example 3. Oh, you get a picture on this one. This is such a typical physics problem. Oh my gosh, you'll do this so many times. Marcus throws a football with an initial velocity of 64 feet per second. That's a number. We usually use those. The height h of the ball after x seconds. So height is going to be my range. That's what I get when it comes out. And seconds is going to be my domain, what I plug in. Okay? Represented by this function. So there's our function. Indicate your function somehow. I'm going to put a box around it. The ball was 5 feet in the air when Marcus threw it. That's going to make a difference too. It was 5 feet in the air when Marcus threw it. Okay. Actually, that just is this. That's not going to affect our domain and range. The graph of the function is shown. Okay, so here we go. Is this discrete or continuous? Well, can I have a portion of a second? Can I have a portion of a height? Can I have 2.5 seconds or 3.5 feet? Yes, I can. So it's got to be continuous. And the reason is because, well, you can have a portion. But even more exact, what we should be writing here is the ball will continuously be in the air or move through the air. You can word it either way. Okay? What is a reasonable domain and range for this function? So here we go. Let's write down the function. The function is h is equal to negative 16x squared plus 64x plus 5. What can we plug in? So just think logically. This is seconds. What can my seconds be? What's the lowest number that I can have for seconds? Well, I can start at 0. Now, the problem is where do I go to find the other information? That's the reason there's a graph. Time is the x-axis. Okay? It starts at 0, goes up, comes back down, and it hits at, notice this is a 2, so it comes back down at 4. I'm going to go over that again. Okay, are you watching? So my seconds is my x-axis. It didn't tell me anything here, but I have to use my graph for information. It tells me that I'm going to start at 0 seconds. It's going to go up and come back down. It's going to end. It's going to come back down by 4 seconds. So I had to use my time was my x-axis. Now my range, we can kind of use this, but it's better just to plug in. There's my lowest, there's my highest, and so I'm just going to plug it in. I could guess what this height is, but we don't know exactly. We know this is our domain. We can figure out our high and our low. Oh, hey, we already figured it was continuous, so that's the reason interval notation. So I'm going to find when, I wish this were in function notation. That's where function notation is really good. You can indicate what you're plugging in. So this is h of 0, and I'm going to find h of 4. I know it doesn't write it that way. This should have been written as h of t or h of x as far as I'm concerned. So I'm just plugging them in now. So h of 0, plug it in, and I get negative 16 plus 64 plus 5. So I'm going to plug in my 0. So I get, well, 0 squared is 0 times negative 16, that's 0. 64 times 0, that's 0. So I get 5. So my initial height, my range, is going to be 5. Let's plug in h equals 4. So I'm going to have negative 16 times 4 squared plus 64 times 4 plus 5. Calculator, let's get a. Okay, so here we go. 4 squared is 16 times negative 16. So that's going to give me a negative 256. 64 times 4 gives me 250. Wait. Why did I come up with a negative? That's just a positive. Hold on. Okay, I messed up. Hold on. Okay, so I messed up. I've been saying that you plug it in and go from here to here. That's because that is, if it is discrete, I'm going to be doing that. When I do an interval, I'm going to look at this graph. I want you to look at this graph with me. So I'm going to tell you where I messed up. Usually we can just plug it in to find our lowest and highest. When we have a graph, we have to pay attention to it. Remember that our range is our y-axis. So it goes from lowest to highest on the y-axis. See where it's at? It's coming right up here. That's our y-axis. When does that happen? That happens at 2 seconds. Okay, I'm going to go over that again. So the reason this one's different is because we have a graph to go off of. So we can look at what our y values can be. Here's our x values. We can look at our y values. Here's our top y value, right? So I can see that I'm going to have to plug in 2 for x. That's going to be the time that I'm going to, because that's going to be my highest. So I'm not going to find h of 4. I was wrong. I want to find h of 2 because that's when it's its highest point. Okay, so I'm going to find h of. If it doesn't give you a graph, you can just use your lowest and your highest. but it gives me a graph. I'm going to have to pay attention to where it turns, okay? So h of 2, I'm going to plug that in. Now, here's the reason I knew I was doing something wrong is because I was coming back to those same things, those same numbers. So I was like, wait, it can't be the same height. My range has to go somewhere. So always pay attention to see if it's reasonable. So now we're going to do this. Negative 16 times 4, that's negative 64 plus 128. That's going to give us 69. So our height, and always check to see if that's reasonable when you're, could that be 69? Well, there's 60. So yeah, that could definitely be, the height was 69. Okay, so sorry about my mistake, but I just wanted to point that out. Now, I want to look at your worksheet, and this is your homework. Okay, this is your homework, and you're going to submit this into us after, and check your answers. Make sure that you're showing us your work. And so one of the things that I would recommend with all of these is look to see, it doesn't ask you this, but look to see, is it continuous or discrete? Okay? You don't need to write it down, but that's going to make a huge difference on how you symbolize your domain and range. Because if it's continuous, it's interval. If it's discrete, whoops, let's spell it right. If it's discrete, then it's going to be set notation. So look to see, always think through which one is it going to be. Okay, and if I were you, when I'm going through it, I would probably mark continuous or discrete. Okay, mark a C or a D so then you can refer to that. This is pretty much like what we were just doing before. If you were in class, I'd probably ask to see if there's one that you wanted to do. This one we kind of already talked about, one like it that has an exponent. So I think you'll be okay. Let me know if you have questions. On the back, what it's asking you to do back here is it wants you to look at the problem and decide which one of these fit it. I'll tell you one big, huge clue. This one has to be a continuous. This one has to be continuous. This one has to be discrete. So you could sometimes eliminate some that would not work because you have to go with discrete and continuous. This one's continuous. This one's discrete. Set notation, interval notation. So pay attention to that. So I picked one that I was going to have us do just so that we could see what's happening. So I picked number 5. The formula x plus y is equal to 180 can be used to find the degrees of supplementary angles. So by definition, supplementary angles are when you take two angles, add them together, they have to be 180 degrees. Find the domain and range of this situation. So what can I plug in for my two angles? Well, if I plug in 0, that means I'm going to add it to 180 to get 180. Okay? So it can be 0 for my x, and of course, I'm going to get 180 back for then my y. So this is a little different. You're not trying to get to 180. This is going to be one angle. This is going to be the other angle. Could I plug in 1? Yeah, and I'd get 179. What if I plug in 179? I'm going to get 1. So it's going to go all the way. X can be 0, and it can go up to 180. It can't be equal to 180. It can't be equal to 0 because I have to be able to add something to it. So it can't be. That's the reason it's parentheses. That's my domain. Now what can my range be? Well, that's a y value. What can I'll plug in for this second one. That's the reason this one's a little different. What can I plug in here? What can I plug in there? Well, if I plug in 0 here, I'm going to plug in everything up to 180, but not including it. So it's like 179, blah, 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 0.9999999, because you're talking about an angle, a measurement. It can be a decimal. So you're going to go up to 180. Oops, hello. I went from largest to smallest. So I can go from 0 to 180. Okay? The other thing is I know this is interval notation. So I knew that it was going to be something like that. I knew it could not be one of these answers because I had to have interval notation. Okay, great. If you have questions, let us know. You know where to find us. Thanks.